The early morning sky over the Norwegian Sea was calm and pale blue. Cold wind moved slowly across the dark water while long waves rolled quietly toward the Arctic horizon. From above, everything looked peaceful. But far beneath that quiet surface, one of the most powerful naval forces in the world was moving into position. A NATO naval task group had been conducting routine patrol operations across the northern Atlantic for several days. The mission was simple on paper: monitor maritime traffic, maintain regional stability, and demonstrate Allied naval presence near strategic Arctic shipping routes. But intelligence reports over the previous 48 hours had raised serious concerns. Russian naval units had left several northern bases and were now operating unusually close to NATO patrol zones. No one knew exactly what their intentions were, and that uncertainty was making commanders nervous. The NATO task group sailed in a type of flexible formation across the open ocean. At the center of the formation was a British destroyer, acting as the command vessel for the patrol mission. Surrounding it were multiple Allied warships from different NATO countries, each contributing its own capabilities to the combined defense network. A Spanish frigate monitored the eastern perimeter. A Norwegian anti-submarine vessel patrolled the northern edge of the formation. 2 American destroyers maintained the outer defensive shield, their powerful radar systems constantly scanning the skies. Together, their sensors created a massive detection bubble stretching hundreds of kilometers across the ocean. Inside the operations rooms of each ship, radar operators carefully watched their screens. Most contacts were routine: civilian shipping, weather patterns, occasional aircraft passing far above. But at that moment, no one yet knew that something far more dangerous was approaching. A new radar contact inside the Combat Information Center of one of the American destroyers. A radar technician suddenly leaned forward. A new signal had appeared on the edge of the radar display. It was faint at first, just a small return on the outer detection range. But within seconds, the radar system automatically began refining the contact. The technician tapped several commands into the console. The signal grew clearer, and what appeared on the screen immediately caught everyone's attention. This was not a civilian ship. The radar signature was large, fast, and moving with the unmistakable pattern of a military vessel. The radar team began cross-checking the contact with international maritime databases. Normally, ships transmit identification signals through the Automatic Identification System, or Aegis. This allows other vessels and authorities to know their identity and location. But the new contact was transmitting nothing. No identification signal, no civilian registry, just a silent radar return moving steadily westward across the Norwegian Sea. That alone was enough to raise suspicion. But when intelligence officers compared the radar shape with known ship profiles, the atmosphere inside the operations room shifted instantly. The vessel matched the profile of a Russian guided missile cruiser. Within minutes, the information reached NATO command headquarters, monitoring the patrol mission. Satellite systems immediately redirected their observation paths toward the new contact. Higher resolution imagery soon confirmed what the radar teams had suspected. The ship cutting through the waves was a heavily armed Russian naval vessel. Its deck carried multiple vertical missile launch systems capable of firing long-range cruise missiles designed for naval combat. These weapons were built specifically to strike distant targets with incredible precision. At full range, they could travel hundreds of kilometers across the ocean before striking enemy ships. And right now, that cruiser was moving toward the NATO fleet. The commander of the NATO task group quickly issued new orders. The fleet shifted into a defensive formation. American destroyers moved forward to create a protective barrier between the Russian cruiser and the rest of the Allied ships. Their powerful Aegis radar systems activated full scanning mode. Helicopters lifted off from several ships to begin aerial reconnaissance. Within minutes, the NATO fleet had transformed from a routine patrol formation into a fully alert defensive network. Every radar system, every sonar sensor, every electronic warfare unit was now focused on one target: the approaching Russian warship. A NATO reconnaissance helicopter soon reached visual range of the vessel. The aircraft remained several kilometers away while its onboard camera zoomed in on the ship. The live video feed transmitted directly back to the destroyer's command center. There was no doubt now. The ship was a Russian missile cruiser, one of the most heavily armed surface combatants in the Russian Navy. Large radar domes rotated slowly above the bridge. Multiple missile launch cells lined the forward deck. These launchers could fire several types of long-range cruise missiles capable of striking both ships and land targets. Everything about the vessel signaled offensive capability, and it was still closing the distance. As the Russian cruiser approached, NATO electronic warfare sensors began detecting new signals. The ship's radar systems were increasing power output. Communication antennas transmitted encrypted bursts of data. At first, this seemed normal. Warships constantly exchange information with other units during operations. But then something unusual happened. One of the Russian radar systems briefly focused directly on the NATO fleet. The signal intensity spiked inside the American destroyer's combat center. Warning indicators suddenly flashed. The radar frequency matched the specific profile stored in NATO threat databases. It was not a search radar. It was a fire control radar. Fire control radar systems are used during the targeting phase of missile launches. They lock onto a specific target and guide weapons toward it with extreme precision. In other words, the Russian cruiser had just aimed its targeting radar directly at the NATO fleet. Inside the operations room, the atmosphere turned tense. This was no longer a simple naval encounter. This was a potential combat scenario. The NATO commander ordered immediate radio contact with the Russian ship. A message was transmitted on international maritime frequencies. The tone was calm but direct. The NATO fleet requested clarification regarding the radar targeting signal and asked the Russian vessel to alter course away from the patrol zone. For several seconds, the radio remained silent. Then a response arrived. The Russian captain replied that his vessel was conducting routine naval operations in international waters. No explanation was offered for the radar lock. The message ended abruptly, but the targeting radar remained active. Readiness levels increased. Missile defense systems were powered on. Radar tracking mode switched to combat configuration. Fighter aircraft stationed at nearby NATO air bases were placed on alert. Everyone understood the potential danger. Because when a warship activates fire control radar, it often means weapons are about to be used. Electronic sensors soon detected another alarming signal. The Russian cruiser's missile launch systems were activating. Small changes in heat signatures and electrical output revealed what was happening below deck. Missile systems were powering up. Inside the NATO command center, officers watched the sensor data in silence. If the cruiser launched cruise missiles from this distance, they would reach the NATO fleet in minutes. But intercepting them over open ocean would be extremely difficult. The situation was reaching a critical point. One final radio message was transmitted to the Russian vessel. The NATO commander issued a clear warning. Deactivate targeting radar and stand down missile systems immediately. For several seconds, the ocean remained silent. Then the response came, but it was not a radio message. While the interceptors raced toward their targets, another invisible battle was already underway. Electronic warfare systems across the NATO fleet activated powerful jamming signals. These signals flooded the airwaves with electronic noise designed to confuse the guidance systems of the incoming missiles. Cruise missiles rely on radar, GPS signals, and terrain mapping to find their targets. If those signals are disrupted, the missile may lose its target entirely. Powerful antennas transmitted waves of electronic interference across the sky. Whether the jamming would work remained uncertain, but every second counted. High above the ocean, the first NATO interceptor reached its target, guided by radar updates from the destroyer. The missile adjusted its path several times per second. Then suddenly, a bright flash appeared on the radar display. A powerful explosion erupted thousands of meters above the ocean. One incoming cruise missile had been destroyed. Cheers erupted briefly inside the operations room, but the celebration ended quickly. 5 missiles were still approaching, and they were now less than 90 seconds away. The remaining cruise missiles dropped even lower toward the ocean surface. Their flight path brought them just meters above the waves. At that altitude, radar tracking became far more difficult. On the screens inside the combat center, the missiles flickered in and out of detection range. Their speed continued to increase. Mach 3, Mach 3.2, Mach 3.5. The system calculated their path again. 2 were heading toward the American destroyers. One was aimed at the British command ship. Another was closing in on the Norwegian vessel. And the final missile was targeting the Spanish frigate guarding the eastern flank. The Russian cruiser had deliberately spread the attack across the entire NATO formation. More launch cells opened,